Well, hi everyone. We have a practice test to work on here. Number one, we're going to solve the system of equations here, if possible. Should there be infinitely many solutions, write a set of solutions that expresses the relationship between the three variables in some way. Okay. Clear enough. Now, you all are free to choose whatever method you want. When I look at it, I would either go Z's or X's. The Y's may require a little bit more work, so I'm going to try to eliminate X's first and find a 2x2 system that has Y and Z. I'm going to take -3 times equation 2 and add it to equation 1 to eliminate the X's. And if I multiply this equation by -3, I got -3x minus 6y plus 3z equals -15. Let's put a -3 right there right now. And then equation 1 is 3x minus 3y plus 6z equals 6. Cancels. I got -9y plus 9z equals -9. Okay, now I'm also going to take, I want to remember this, I'm going to take, I did the x's, right? Yeah. I'm going to take -5 times equation 2 and add that to equation 3. So I'm using equation 2 combined with each of the other ones first. And if I multiply it by -5, I'm looking at -5x minus 10y plus 5z equals -25. And equation 3 is 5x minus 8y plus 13z equals 7. All right, canceling. So I'm looking at -18y plus 18z equals -18. Okay, this is looking a little suspicious to me, but I have yz here, yz here. Now I'm going to do this 2x2 system. The -9y plus 9z equals -9. -18y plus 18z equals -18. If I multiply this one by 2, let's go -2. I'll have -18y plus, no, positive 18y minus 18z plus 8 equals positive 18. And here I'll have -18y plus 18z equals -18. And everything cancels. 0 equals 0. So there are infinitely many solutions. Because this is true. All right. Now, our task here should there be infinitely many solutions, we're going to write a set of solutions that expresses the relationship between the three variables in some way. So I'm going to take this equation, -9y plus 9z equals -9. One of the equations where I'm down to two variables. It doesn't matter which one you use. I'm going to solve it for y. So I'm going to subtract 9z from both sides. I want to divide through by 9. I'll do that eventually. I'll resist the urge to do that right now. negative 9z. Not that I have to, but now I'm going to divide by negative 9, clear through on both sides, and I'm looking at y equals z plus 1. Okay, that's z plus 1. Now, I'm going to let's let A equals Z. Or probably put that the other way around. Okay, so when I go to express this, X, Y, and Z, that makes y equal a plus 1. So I'll put a plus 1 here. I already said let's let z and a be equal. And now let's figure out what x is. I'm going to use that second equation. X plus 2y. I'm making y be a plus 1 now. Minus z, which I'm saying is a now, equals 5. And I'm just going to solve this for x. X plus 2a plus 2 minus a equals 5. X plus a plus 2 equals 5. Let me subtract 2 from both sides. I've got x plus a equals 3. I will subtract a. X is equal to 3 minus a. So in terms of a, which is basically in terms of z, we have a relationship. I chose to let y equal z plus 1. I chose to solve for y first. You could have chosen to solve for z first. The answer would look a little different, but the relationships will still work. So this is what I mean. We don't know what the infinitely many solutions are, but we do know they would have this relationship. And I could say let a equal 5. If a is 5, I'll bet you z would be 5, y would be 6, and x would be 3 minus 5, or negative 2. That's one of the infinitely many solutions. I could change a to 11. Then this would be 12, and this would be negative 8. 3 minus 11 is negative 8. There's infinitely many solutions, but not everything is a solution. Okay. Number 2. Write the equation of a parabola that passes through negative 1, 9, 0, 6, and 1, 7. Well, one thing we've got to remember with this is y equals ax squared plus bx plus c is a form of a standard for a general form for a parabola. And we have various solutions to that. xy here, and xy here. So we're going to put that in 3 times. Now, let's do the first one. 9 equals a times negative 1 squared plus b times negative 1 plus c. So 9 is equal to a minus b plus c. The second one, let's just remember that. We're going to write a system doing this 3 times. Y is 6 equals a times 0 squared plus b times 0 plus c. That's 0, that's 0, 0. So 6 is equal to C. Remember that. And then a third time, 7 equals A times 1 squared plus B times 1 plus C. 1 squared, so it's A plus B plus C. All right. Our system, A minus B plus C equals 9. C equals 6. And A plus B plus C equals 7. All right. Since I already know C is 6, I'm tempted to put 6 in here and here. A minus B plus 6 equals 9. And A minus B would be 3 if I subtract 6 from both sides. A plus B plus 6 equals 7. Subtract 6 from both sides, I got A plus B equals 1. Now, A minus B equals 3. A plus B equals 1. If I add those together, I got 2A is equal to 4. Divided by 2, I'll get A is 2. And A plus B, I'll use this one, which is 2 plus B is equal to 1. Subtract 2, I got B equals negative 1. So I have my A, I have my B, I have my C, and now I'm ready to write my equation. Let's do it down here. Y equals A, which is 2x squared plus, I'll go minus 1x plus 6. So there's my parabola equation. All right, partial fraction decomposition, number 3. So, this is 3x minus 1 over x, how's this factor in? X plus 5 times x minus 3. So 3x minus 1 over x plus 5 times x minus 3 is equal to A over x plus 5 plus B over x minus 3. And we are going to figure out what A and B are here. To solve this equation, I would multiply by the least common denominator, x plus 5 times x minus 3. First time, those cancel and that cancels, so I'm left with 3x minus 1. The x plus 5's cancel, but the x minus 3 did not, so it's A times x minus 3. And then the x minus 3's cancel, so I got B times x plus 5. Well, what do we have? We have 3x minus 1 equals ax minus 3a plus bx plus 5b. 3x minus 1 equals, let's go ax plus bx. I'll just change the order here, minus 3a plus 5b. This part is equal to the negative 1. This part is equal to the 3. Let me write that. 3x minus 1 equals a plus b times x minus 3a plus 5b. Now I'm going to set up a system. It says a plus b is equal to 3. since this is the only coefficient of x we have here, and this is the only coefficient of x, and their things are equal. So a plus b is 3. Negative 3a plus 5b would have to be the constant, which is negative 1. We solve this system. We've got two factors here to figure out. And then we're going to know what a and b are, and we'll write our partial fraction decomposition. I'm going to multiply this by 3, and I've got 3a plus 3b equals 9. And I got negative 3a plus 5b equals negative 1. Cancels. I got 8b equals 8. And b is 1. So I got b. Yay. B is 1. A plus b is 2. So a has to be 2. So here we go. A is 2. So that's over the x plus 5. B is 1. So that's over the x minus 3. And that is equal to my 3x minus 1 over x squared plus 2x minus 15. There's the partial fraction decomposition. Okie dokie. Put my brackets around our matrices here. This portion of the test. Okay, give the dimensions of B. It is rows by columns. 1, 2, 3 rows, 2 columns. This is a 3 by 2 matrix. Give the matrix that represents 2B plus 4B, 4D. So 2b, that is 2 times the negative 4, negative 9, negative 4, 4, negative 7, negative 9 matrix, plus 4 times the negative 4, negative 5, 8, 8, negative 9, negative 7 matrix. Now I'm taking this scalar times this matrix, and I'm getting negative 8, negative 18, negative 8, 8, negative 14, negative 18, plus, and then 4 times that scalar gives me negative 16, negative 20, 32, 32, negative 36, negative 28. I am breaking lead like crazy. I'm getting my final answer. Negative 8 plus negative 16 is negative 24. Negative 18 plus negative 20 is negative 38. Negative 8 plus 32 is 24. 8 plus 32 is 40. These are just corresponding cells when you're adding and subtracting. Negative 14 and negative 36 is negative 50. Negative 18 and negative 28 is negative 46. This is what I believe the answer is to that one. All right, give the matrix that represents D times E. D, negative 4, negative 5, 8, 8, negative 9, negative 7. E, 4, 9, 3, negative 4. All right. First row, first column. I'm going to take negative 4 times 4 plus negative 5 times 3. First row, second column. Negative 4 times 9 plus negative 5 times negative 4. Second row, first column, 8 times 4 plus 8 times 3. Second row, second column. 8 times 9 plus 8 times negative 4. Third row, first column. Negative 9 times 4 plus negative 9 times, nope, negative 7 times 3. Third row, second column. Negative 9 times 9 plus negative 7 times negative 4. Okay. This is negative 16, negative 15. That gives me negative 31. Negative 36 plus 20 is negative 16. 32 and 24 make 56. 72 and negative 32 make 40. Negative 36 and negative 21. That's negative 57. Negative 81 plus 28. That is negative 53, I believe. Yeah. All right. That's the answer I'll stick with there. Use your calculator to find e squared. All right. So I'm going to go to matrix. I've got some editing to do here. E is what? A 2 by 2. So I'm going to put a 2 by 2. And I'm going to go 4, 9, 3, negative 4. And then I'm going to quit. I'm going to go second matrix. I've changed A to that 2 by 2. I probably should have used the E option there, but I didn't. A squared, which is going to be my E squared. Hit enter. 43, 0, 0, 43. Interesting. Okay. That's number 7. Number 8, the inverse matrix of E. Now this one I'm asking you to show your work. E is 4, 9, 3, negative 4. All right, the determinant of E. I'm going to take 4 times negative 4 minus okay, 4 times negative 4, A times D minus B times C, so minus 9 times 3. We're looking at negative 16 minus 27, which is negative 43. So we go 1 over the determinant, 1 over negative 43 times this matrix here, which is, I switch these two, negative 4 and 4, and I change the sign of these two. That's negative 3 here, that's negative 9 here. And then I'm going to write it with fractions. Negative 4 over negative 43 is positive 4 43rds. Negative 9 over negative 43 is 9 43rds. Negative 3 over negative 43 is 3 43rds. And then 4 over negative 43rds is negative 4 43rds. All right, so that's what you do there. Remember, if you have time to check these too. You can, if you want to use your calculator to make sure you're doing this correctly. But I do want to see the work. I want to see the determinant and the swapping of these and the changing of signs there. Okay, number 9. Give a matrix calculation from the above matrices. It would be impossible. The above, that means the matrix we have here. There's several options you can do there. I can't add A and B. I can't add C and D. I could add those two. I can't add A and C. I can't add or subtract. They have to have the same dimensions for addition. There's also, you know, you've got a 2 by 3. A 2 by 3. I couldn't take this, well, I could. I could multiply AB or BA. 2 by 3, 3 by 3. But if I do a 3 by 3 times a 2 by 3, I can't multiply C times A. That's the one I'll go with. All right, C times A, because, explaining why. C is a 3 by 3. A 3 by 3 matrix times a 2 by 3 matrix is undefined because the columns of the first does not match the number of rows of the second. Okay. The 3 and 2 are not matching. They're not the same. Identity matrix, and keep in mind on 9, I gave you like 4 or 5 other examples with addition or subtraction that you could have used as well. I just chose try a multiplication. Now number 10, give the identity matrix of a 2 by 2. Well, here it is, 1, 0, 0, 1. And a 3 by 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. Explain why they are called identity matrix. Okay. When these are able to be multiplied by any matrix, sometimes it's not defined because of the columns and rows not matching up, then the product will be that other matrix. It's like multiplying by 1. Okay. Matrix equation 1. My coefficient matrix 1, 3, 4, 2, 7, 5, 3, 10, 4 times my variable matrix x, y, z is equal to my constant matrix 7, 10, 27. All right, let's do a little bit of work here. So I'm going to take my coefficient matrix and figure out what its inverse is using the calculator. And I'm going to put it here. I'm going to multiply it on each side of this matrix equation. Alrighty. Second matrix, edit, A, 3 by 3, 1, 3, 4, 2, 7, 5, 3, 10, 4. All right, second quit, second matrix, A inverse, right there. That's not bad. I may just leave it. We've been changing it to fractions. That's a decimal, so I'm just going to leave that. 4.4, negative 5.6, 2.6, negative 1.4, 1.6, negative 0.6, 0.2, 0.2, negative 0.2. And let me write it here as well. All right. This times this is 100,010,001. This one I'm going to work at figuring out real quick like here. So I'm going to go second matrix and B, oops, I need to edit B, not that one, second quit, second matrix, edit B, not A. It is 3 by 1, those numbers look familiar. We need 7, 10, and 27 this time. 7, 10, 27. Second quit, second matrix, A inverse times second matrix B equals 45, negative 10, negative 10, negative 2. So x, y, z equals 45, negative 10, and negative 2. All right. And then we could write it in an ordered triple here, x, y, z equals 45, negative 10, negative 2. 45 plus, I'm checking right now, 3 times negative 10 plus 4 times negative 2 equals 7. 2 times 45, second equation, plus 7 times negative 10 plus 5 times negative 2, 10. And 3 times 45 plus 10 times negative 10 plus 4 times negative 2, 27. That checks out. Okay. There we go, guys.